I bet you've seen those shape-shifting robots in sci-fi movies. But what if I told you they're not just fiction anymore? We're about to dive into a world where robots can melt like the T-1000, then reform into solids, all while performing complex tasks. And the inspiration behind this mind-bending tech, it's not some advanced AI or alien technology. Now you might be wondering, what's so special about sea cucumbers? Well, these bizarre ocean dwellers have a superpower that's caught the attention of engineers and roboticists. They can change the stiffness of their bodies at will. One moment they're rigid, the next they're soft and flexible. This ability allows them to squeeze through tiny cracks in coral reefs or become rock hard to deter predators. But here's the thing, this isn't just a cool party trick. It's a survival mechanism that's been honed by evolution over millions of years. And now, we're learning how to replicate it with our own technology. So how do we go from a squishy sea creature to a high-tech robot? It turns out, the key is in the materials. Engineers have developed a groundbreaking combination of gallium, a metal that melts at just 86 degrees Fahrenheit, and magnetic particles. This creates a substance that can transform between solid and liquid states, just like our sea cucumber friends. But here's where it gets really cool. Unlike sea cucumbers, which change their body stiffness through a complex biological process, these robots can be controlled entirely by external magnetic fields. Let's think about this for a second. How exactly do these robots work? The secret lies in the unique properties of gallium. This metal has a melting point of around 86 degrees Fahrenheit, 30 degrees Celsius, which is just above room temperature. When we combine it with magnetic particles, we create a material that's perfect for shape-shifting robots. Here's how it works. When exposed to an external magnetic field, the magnetic particles inside the robot generate heat through a process called induction. This heat causes the gallium to melt into a liquid form. Once the magnetic field is removed or adjusted, the robot cools down and resolidifies into its original shape. It's like having a miniature controllable version of the T-1000 right in the palm of your hand. These robots can transform from solid to liquid state, allowing them to squeeze through tight spaces with ease. Controlled by magnetic fields, these robots can be manipulated with incredible precision. They can morph into different shapes on demand, opening up possibilities for navigation through complex environments like the human body. It's like having a remote-controlled liquid that can solidify on command. In medicine, these robots could revolutionize how we approach delicate procedures. Imagine removing foreign objects from the body without invasive surgery. In one experiment, researchers demonstrated how these robots could remove objects from inside a model human stomach. The robot melted down, surrounded the object, then resolidified while holding onto it. This technology could revolutionize how we approach everything from surgery to delivering targeted drug therapies. It's like having a microscopic surgeon that can reach places we've never been able to before. In industry, these shape-shifting marvels could be game changers. Imagine repairing complex machines from the inside out, or assembling delicate electronic components in confined spaces. These robots could flow into tight areas where traditional tools simply can't reach, then solidify to perform precise tasks. In hazardous environments like nuclear facilities, these robots could perform repairs without risking human lives. It's like having a Swiss Army knife that can transform into any tool you need, on demand. In space exploration, these robots could be game changers. Imagine sending flat-pack robots that can reassemble into larger structures once they arrive at their destination. They could build habitats on Mars, repair satellites in orbit, or even construct self-repairing spacecraft components. It's like having a cosmic Swiss Army knife that can adapt to any challenge in the harsh environment of space, opening up endless possibilities for future missions and off-world construction. Of course, no groundbreaking technology comes without its challenges. One major hurdle is ensuring precise control over these robots' movements, inside complex environments like the human body. Researchers are working on improving tracking methods so doctors can monitor their exact positions during procedures and ensure they don't stray off course. Another challenge is raising the melting point of gallium-based materials so they remain stable at higher temperatures without liquefying prematurely. As we look to the future, the potential applications for these shape-shifting robots seem limited only by our imagination. From revolutionizing medical procedures to transforming space exploration, these tiny marvels represent a whole new frontier in robotics and engineering. And to think it all started with a squishy sea cucumber. Who knows what other incredible technologies might be hiding in nature just waiting for us to discover them. We're witnessing the birth of a technology that could fundamentally change how we think about robotics and machines. From healing our bodies to exploring distant planets, these shape-shifting robots represent the next frontier in engineering. If you're as excited about this breakthrough as I am, hit that subscribe button and join me on this journey into the future of technology. And remember, sometimes the most revolutionary innovations come from simply paying attention to nature's ancient wisdom. Leave a comment below on your thoughts about this technology or what you would like to see in a future video. Thank you for watching the Crazy Science Topics channel.